So let's move along now. Let's look at something called the tangent ratio. And if you notice here, I've got 3 different triangles. But are they really different? What I want to show you something is very, very interesting. I'm going to choose my reference angle here. There's my reference angle. That's the guy I want to choose. But I also want to show you a couple other things here which are quite interesting. I want to show you this particular triangle, this one here. So I'm going to pick it up and I'm going to place it right here. And if you notice, it is a perfect fit. Now, the interesting thing is, what happened to that reference angle? Absolutely nothing. That reference angle, whether we're talking about the big triangle or this little triangle, as you notice, that reference angle is exactly the same. There's no difference there. So let's take a look at this bigger triangle here. Well, this particular triangle, I want you to notice as well. If we flip it and we put it right in here, look at that. It fits absolutely perfect. But what do you notice about the reference angle? Absolutely nothing. So that tells you a whole bunch of stuff here. That tells you it doesn't matter if you're talking about a triangle that's got a huge length here and just a short little rise here. This reference angle is exactly the same as, look at this one. And I'll do it in a different color here. The smaller triangle, this one here. Same reference angle. And then finally, our smallest triangle, which is right here, has the same reference angle. This will always be the same. So thousands of years ago, the Greeks turned around and said, wow, look at this. That must mean that there's got to be a relationship between this side and that angle. Well, in fact, there is. Let's take a look at this. Take a look at my next little thing. I've got the same triangles here again, but now I've attached numbers to them. So let's take a look at this largest triangle again. And if you look, there's the largest triangle, and there's its height. So I'm going to do a relationship between this side and this side, which if you think about it, and if you put your eyeballs on this, you know that this side is always going to be the opposite. And this side is going to be your adjacent. Okay, so here we go. What is the relationship? Well, let's look at ratios. Yes, fractions, one over the other. So if you go all the way out here, you'll notice that this side is actually 3 over, well, there's 3 up to here. That is another 3, making this 6. All the way up to 9. So this actually is a ratio of 3 over 9, which if you think about it, well, wait a second, that's 1/3. All right, well, let's take a look at the next triangle, which was this one from here to here. And if you look, this is a height of 2, all right, 2 over the length of, oh, look at that, 6. Okay, that's 2 over, wait a second, that's 1/3 as well. Holy smokes. Let's take a look at the smallest triangle. Well, that's easy. That's a height of 1 over 3. Wait a second. 1 over 3? What are you saying? Well, what I'm saying here is it doesn't matter the length of the sides. As long as that angle does not change, all of the lengths of these sides, all of these ratios are exactly the same. Well, folks, that's what tangent is about. Tangent looks at the relationship of the angle here. So I'm going to put the angle as a little symbol like that, okay, as opposite side over adjacent side. Now, how do you remember tangent is opposite over adjacent? Well, it's part of a bigger word that you'll learn a little later on, but it's called TOA. TOA, tangent, opposite, adjacent. And we'll see how that works in the very, very next lesson.